Ladies and gentlemen, and all the friends who join us online, good morning, good afternoon, or good evening, wherever you are. Welcome to 2021 Taiwan-US Smart Manufacturing Summit and MOU signing ceremony on industrial cooperation. We are very happy and very excited today that many distinguished guests and speakers are joining us. They're going to share with us how AI, artificial intelligence, can be incorporated into taking smart manufacturing and digital transformation to the next level. And together, we are going to talk about opportunities about how to have more cooperation between Taiwan and the US navigating through this new global supply chain. To begin today's summit, we'd like to firstly invite Zhiqing Yang, Deputy Director General of Industrial Development Bureau, IDB, under the Ministry of Economic Affairs, MOEA, Taiwan, to give us the opening remark. Let's welcome Deputy Director General Yang.
Thank you. Deputy Secretary Briel of Pennsylvania Department of Community and Economic Development. Team Leader Plagens of the Global Advanced Manufacturing Team, U.S. Department of Commerce. Deputy Section Chief Gately of AIT Commercial Section. Executive Director Reed of Pittsburgh Robotics Network. Chairman Zhi of TAIROA. Vice President Su of ITRI, and all the speakers. Ladies and gentlemen, good morning and good night. The global economy has undergone rapid change in recent years. From the U.S.-China trade and tech war in 2018 to the outbreak of the COVID-19 pandemic in 2019, major events such as lockdown of cities in many countries around the world and the deconstruction and the restructuring of the international industrial supply chain in 2020 has greatly impacted the company not only in production and marketing, but also in strategy of global layout of supply chain and factory operation management. On the other hand, in response to the era of highly customized consumption, the flexible and variable market requirements are testing the smart manufacturing technology capability of various suppliers. The Industrial Development Bureau, IDB, of the Ministry of Economic Affairs, MOEA, Taiwan, has initiated the Smart Machinery Industry Promotion Program in 2016. Due to the different scales and the capacities of manufacturers, the program is to prototype our assistant in digitalization, digital optimization, digital transformation, and upgrading, and to achieve the vision of intelligence machine industrialization and industrial intelligence, and moving toward the goal of making Taiwan an Asia high-end manufacturing center. In the past 2 years, the government has also promulgated the statutes for industrial innovation to attract Taiwan enterprises overseas to come back and reinvest in Taiwan, especially in smart transformation. As well all know, in addition to the well-known AI cradle, Carnegie Mellon University, CMU, Pittsburgh of Pennsylvania, in recent years, under the promotion of the Pittsburgh Robotics Network, PRN, with more than 100 research and production members, has developed into a global AI robot industry center. Following the signing of an MOU in the semiconductor, medical, and advanced manufacturing industry with the Greater Phoenix, Arizona, last few months, today we are pleased to see the Pittsburgh Robotics Network, PRN, an AI hub in Pennsylvania, USA, signing an MOU in the AI smart manufacturing industry with Taiwan. It can be foreseen the smart link of important industries between the US and Taiwan have been fully launched, and the brand new industrial value chain will open up a new era for more Taiwan-US industrial cooperation and business opportunity. I am pleased to be here for the 2021 Taiwan-US Smart Manufacturing Summit and witness the MOU signing of the Taiwan-US Industrial Cooperation by Pittsburgh Robotics Network, Taiwan-USA Industrial Cooperation Promotion Office, TUSA, and the Taiwan Automation Intelligence and Robotics Association. My best wishes to this grand event, a total success, and all my friends with great health and prosperity. Thank you all.
Thank you very much to Deputy Director General Yang of IDB. We do look forward to a lot more industrial cooperation between Taiwan and the US in the future. And today we also have Mr. David Briel, Deputy Secretary of Pennsylvania Department of Community and Economic Development, with us online. So next we'd like to invite Mr. Briel to also share a few words with us. Over to you, Mr. Briel.
Thank you very much. So on behalf of Pennsylvania Governor Tom Wolf and our Department of Community and Economic Development Secretary Dennis Davin, now I would like to take this opportunity to congratulate Joel and the Pittsburgh Robotics Network, as well as the Taiwan-USA Industrial Promotion Office and the Taiwan Automation, Intelligence, and Robotics Association, along with our partners at the Ministry of Economic Affairs for concluding this, for all the work to conclude this agreement. We'd also like to thank our partners at the Taiwan Economic and Cultural Office in New York, who has granted us numerous opportunities to interact in Taiwan over the past few years, which has helped to cement further our deep ties between Pennsylvania and Taiwan. And we have an annual trade with Taiwan of over $1.3 billion. Taiwan, of course, is the ninth fastest growing investor in the US, and we certainly look forward to seeing more of that in Pennsylvania. As part of our commitment to Taiwan, Pennsylvania will, in Q1 2022, be opening a full-time trade and investment office in Taipei. So we look forward to reinvigorating our efforts in Taiwan. And last, I would just like to say we would all like to take this opportunity to invite Taiwanese companies to come to Pittsburgh to take a look at what Pittsburgh has to offer. I mean, a leader in robotics, artificial intelligence, autonomous vehicles. It's one of the few places in the US where you get that world-class research and development, as well as a cost-competitive environment where you can also manufacture. So we look forward to seeing you in 2022 in Pittsburgh, and thank you very much for this opportunity.
Thank you very much to Mr. David Briel, and we really want to pay a visit to Pennsylvania when the pandemic subsides. Thank you so much. We hope to see you in person as soon as possible. And next, we'd like to welcome Ms. Pam Plagens, team leader of the Global Advanced Manufacturing Team of the International Trade Administration, U.S. Department of Commerce. Let's welcome Ms. Plagens.
Greetings. I'm Pam Plagens, Advanced Manufacturing Team Leader for the U.S. Commercial Service, the trade promotion arm of the U.S. Department of Commerce. U.S. Department of Commerce International Trade Administration. Our mission is to strengthen the U.S. economy and help create jobs by expanding U.S. exports. We're currently celebrating Manufacturing Month, the month of October in the United States. In 2020, U.S. exports of manufactured goods totaled $1.168 trillion. My team of trade specialists around the world focuses on the exports of additive manufacturing, automation and robotics, as well as industrial materials and machinery. Our services include consulting, market intelligence, and buyer, partner, distributor, business-to-business engagement. It looks like my computer has decided to freeze, so we're going to go. Okay, and business-to-business engagement. U.S. manufacturing output was valued at $5.7 trillion in 2019. Prior to COVID, and U.S. manufacturing industries are recovering strongly in 2021. According to current U.S. Census data, manufacturing accounts for nearly 11% of total U.S. economic output and employs 12.4 million American workers, with U.S. manufacturers adding more than 135 jobs since July. Growth in U.S. manufacturing has been broad-based in 2021, with 17 out of 18 major manufacturing industries reporting expansion in July, including machinery and computer and electronic products. As the manufacturing sector tread further into the realm of advanced manufacturing, it's unearthed the many challenges that accompany blending together the digital and the machine. The U.S. manufacturing industry faces the necessity of learning new skills and retooling a workforce to program and work alongside machines. Also, with the inclusion of rapidly advancing technologies like additive manufacturing, the industrial internet, and AI, to name a few, the industry must work hard and fast to develop standards that enable a fair and safe trading ecosystem. Both the Taiwan-US Industrial Cooperation Promotion Office, TUSA, and the Taiwan Automation Intelligence Robotics Association, TAIROA, are strong partners with the commercial section at the American Institute in Taiwan. I also want to thank TAIROA for sharing their industrial insights during our Asia Advanced Manufacturing Coffee Chat in May. It was a great opportunity to engage U.S. companies and give them insights into the market in Taiwan. The Memorandum of Understanding between TUSA, TAIROA, and Pittsburgh Robotics Network signals the enduring business ties between Pittsburgh, Taipei, and by extension, the United States and Taiwan. Together, Taiwan and Pittsburgh are building the supply chain resilience that is critical for future success of both the U.S., Taiwan, and global economies. Congratulations. As I know, in the beginning of 2022, there'll be a big manufacturing trade show in Taiwan, the TIMTOS and TMTS 2022 in Taipei, from February 21st to the 26th. We look forward to the combined event, which will maximize trade opportunities between our markets. Thank you so much for inviting me today. Have a great program.
Thank you very much to Ms. Pam Plagens. We really appreciate your participation today. And of course, today's summit is not possible without the great support from the American Institute in Taiwan, AIT. And today, online with us, we have AIT's Deputy Commercial Section Chief, Mr. Andrew Gately. And next, please welcome Mr. Gately.
Deputy Director Yang, Deputy Secretary Briel, Advanced Manufacturing Team Leader Pam Plagens, Chairman Si from TAIROA, and Pittsburgh Robotics Network Executive Director Reed. Distinguished speakers, online guests, ladies and gentlemen, for those of you in Taiwan, Zaoan, for those of you in the United States, Wanan. My name is Andrew Gately. As mentioned, I'm the Deputy Chief of the Commercial Section here in Taiwan at the American Institute, which represents the interests of the U.S. government in Taiwan. It is an honor for me to give remarks at the 2021 Taiwan-US Smart Manufacturing Summit and MOU signing on industrial cooperation. My colleague, Pam Plagens, as mentioned in her remarks, is a part of the U.S. Department of Commerce's Commercial Service, which is responsible for industrial cooperation and promoting trade and investment between the United States and Taiwan. I would like to thank TUSA and TAIROA for being remarkable partners to both the American Institute in Taiwan and the U.S. Department of Commerce. Over the years, we've collaborated on numerous impactful projects and initiatives to promote bilateral trade and investment between the U.S. and Taiwan. In 2018, TUSA and AIT led a trade mission to Pennsylvania that traveled to both Pittsburgh and Philadelphia to promote bilateral trade, investment, and technology cooperation. We hope that our teams can collaborate on a similar trade mission in 2022. Speaking of Pennsylvania, I am thrilled that we are witnessing today the MOU signing ceremony between TUSA, TAIROA, and the Pittsburgh Robotics Network. It is remarkable how the state of Pennsylvania has created state-funded programs such as Manufacturing PA Innovation that works to connect academia with industry and facilitate growth in the advanced manufacturing sector. The United States has a great partner in Taiwan in the advanced manufacturing sector. As one of the world's most important ICT manufacturing hubs, Taiwan is a global high-tech supply chain center due to its advanced R&D capabilities in semiconductors, 5G telecom, and other ICT-related fields. I believe that U.S. systems integration solutions and automation solutions are extremely complementary to the products produced here in Taiwan. Opportunities for cooperation are truly endless. In terms of upcoming events, my team at AIT is working closely with TAIROA to plan a U.S. Solutions Symposium that will be part of the Automation Taipei coming up in December, on December 16th. This event will feature 10 U.S. companies operating in industrial automation, robot technology, ICT and software, machine tool and general machinery, hardware, and factory equipment. My team will be offering virtual introductions for Taiwan companies that are interested in participating, and obviously also to U.S. companies as well. Before I close, I would also like to acknowledge the U.S. companies Rockwell Automation and Epicor Software, both close friends of AIT where I work, that you'll all be hearing from later today during this summit about smart manufacturing solutions that they are offering in Taiwan. In closing, let me say that we are very fortunate to have with us today some of the most forward-looking businesses in the world working on advanced manufacturing, automation, and digital transformation. I have every confidence that the Taiwan-US cooperation will be successful in its strategic goal to restructure global supply chains and expand bilateral industry cooperation. Congratulations and thank you.
Thank you very much to Mr. Andrew Gately from AIT. All right, ladies and gentlemen, next is the moment that we all been waiting for. PRN on the US side and TUSA and TAIROA on Taiwan side are going to sign an MOU on industrial cooperation in the field of smart manufacturing. So to witness this very important MOU signing, online here with us, we have three of our previous speakers, Deputy Director General Yang, and also Deputy Secretary Mr. Briel, and also Deputy Commercial Section Chief of AIT, Mr. Andrew Gately. And next, I'm going to invite Mr. Joel Reed, Executive Director of Pittsburgh Robotics Network, PRN, and also Stephen Su, CEO of Taiwan-USA Industrial Cooperation Promotion Office, TUSA, and Guo Yisi, Chairman of Taiwan Automation Intelligence and Robotics Association, TAIROA, to sign the MOU. Okay, Mr. Reed, Mr. Si, and Mr. Su, you ready? Okay, all right, please sign the MOU. We hope by signing an MOU, we can facilitate the cooperation between Taiwan and the US on the development of robotic, automation, and smart manufacturing technologies. All right, please show the MOU to the camera, ladies and gentlemen. All right, and to celebrate this moment, we are going to have a photo together. So joining us, we have Mr. Yang and also Mr. Gately and also Mr. Briel with us. Let's have a photo together. Please look at the camera right now. A big smile, everyone. We really are honored and also very, very happy for this milestone between Taiwan and the US. All right, so we are going to do a second photo. And for the second photo, we are going to invite more people to join us. And for that, Mr. Reed and also Mr. Si, Mr. Su, you can put your MOU down now. Thank you. And to join us, you can see right now Ms. Pam Plagens from U.S. Department of Commerce. Would you please say hi to everybody? Hi. And also we have Hua Yu Lin, the Director of Metal and Mechanical Industries Division, IDB and MOEA. Welcome. We have our speakers, Jay Lee, Member of the Board and Vice Chairman of Foxconn Technology Group, Hong Hai Precision. Welcome. And also Chen Tan Lien, Chief Technology Officer of Industrial Automation Business Group, Delta Electronics. Welcome. And Charles Tam, Country Manager of Rockwell Automation, Taiwan. Welcome. And Robert Chen, Country Manager of Epicor Software Corporation. And also joining us, we have Wanjun Chen, Secretary General of TAIROA. Hello, and Jimmy, of course, C.Y. Liang, Executive Secretary of TUSA. All right, we have everybody right now. We're going to do another group photo. Everybody, please look at the camera right now. Yeah, I see a lot more people from the AIT. All right. Okay, we have Mr. Gately and Mr. Briel and 4 more people, the staff from AIT. Thank you so much for joining us. Okay, 3, 2, 1. Thumbs up, everyone. Thumbs up, all right? Okay, 3, 2, 1, let's have a photo. We'll send a screenshot to you after the forum today. Okay, thank you again. Thank you so much. Thank you, and we are very happy and to celebrate together the MOU signing today. Thank you once again for your participation, and we will be back to our summit right now for the keynote speech. Okay, ladies and gentlemen, we have 5 keynote speeches for you today, and we have a panel discussion in the end of the summit. For the first talk, it's going to be brought to you by Mr. Joe Reed, Executive Director of Pittsburgh Robotics Network, PRN. And we know that Joe is an expert for robotics business, and also he has 25 years of strategy development and startup experience. So he has a lot to offer to us today. He's going to share with us some more information about PRN and smart manufacturing in the US. So over to you, Mr. Joe Reed, Executive Director of PRN.
Thank you so much. This is incredibly exciting. We, on behalf of the Pittsburgh Robotics Network, our members and our stakeholders in the Pittsburgh region, the state of Pennsylvania, and maybe more broadly in the United States, we're really honored to have signed this agreement today. As mentioned, I'm the Executive Director of the Pittsburgh Robotics Network. And I want to thank all the representatives and team members who've made this possible. We thank the Taiwan-US Industrial Cooperation Promotion Office and Stephen Su, thank you so much. The Taiwan Automation Intelligence and Robotics Association and Chairman Ho-Ai Shu. We're really excited to form this partnership, and we're looking forward to exploring industry opportunities together. Let me also thank Deputy Secretary David Briel and the Pennsylvania Department of Community and Economic Development, and Deputy Director General Chi-Ching Yang and the Ministry of Economic Affairs. And finally, Department Commercial Section Chief Andrew Gately of the American Institute for making this introduction, for helping facilitate our signing today between the PRN, TUSA, and TAIROA. In my keynote, I'm going to spend my time to introduce you to the Pittsburgh robotics community. I want to show you the areas that are leading to what we are calling smart manufacturing, driven by artificial intelligence and autonomous robotic systems. And I will invite you to come connect with us as part of this new alliance. You likely it was already mentioned about Carnegie Mellon University. And many people already know about CMU's leadership in advanced robotics and AI. But many people, and we can stay on the first slide, please, and I will advance the slides. Many people do not know, and go back to the title slide, that Pittsburgh is one of the world's top robotics business ecosystems. Many autonomous technologies, including self-driving vehicles, started here in Pittsburgh at Carnegie Mellon University. And today, Pittsburgh is a worldwide center of research and development for autonomous car solutions, with nearly every major company located and actively testing in Pittsburgh. CMU is also credited with launching the artificial intelligence industry, and we now have nearly 100 businesses working on a wide range of autonomy systems. And these companies are changing the way that we work, the way we move, and the way we live in our daily lives. And with all of this, we consider Pittsburgh to be the robotics capital of the world. It is our mission at the PRN to connect many of you in the audience and our new partners with this rapidly growing regional cluster. And we want to work together to accelerate the overall adoption of autonomous systems. This is why we're pleased to form this partnership with the Taiwan-US Alliance and the Taiwan Automation Intelligence and Robotics Association. And we are very eager to meet all of you and to begin cooperation according to the outlined initiatives. If we could please go back to slide 2, just one slide back. One more slide back. There we go. So with this slide, I wanted to address, yes, the one with the smokestacks. Why Pittsburgh? We sometimes hear that question, and I want to give a little bit of a history background, but in the interest of time, I'm going to simplify this greatly. In the 18th century, Pittsburgh had one of the largest mineral deposits of coal in the United States, and coal ultimately became steel. And steel built our railroads in the United States as our country was expanding rapidly. There was a company that was formed during this era, Westinghouse, which should be known to many, that was founded and based in Pittsburgh. And Westinghouse had invented the railway air brake. And this ultimately became the company, their innovations, and their engineering staff, a deep source of innovation and talent in our region. And it was Westinghouse that introduced robots to the general public in the 1939 New York World's Fair with a working humanoid named Electro, which is pictured here in the slide, and his sidekick, Sparko. Next slide, please. I also want to give the other side of Pittsburgh as a introduction, and we have a significant history in industrial engineering and manufacturing. This is why many of you might know why we have the Pittsburgh Steelers, a world-renowned American football team. But we have this significant capability still today in advanced manufacturing with a high number of manufacturing establishments and a significant output to our local and U.S. economy. And manufacturing and advanced manufacturing remains a significant employer in our local region. In addition to the nearly 3,000 manufacturing establishments, Pittsburgh has over 50 global manufacturers with world headquarters in our region. Next slide, please. I wanted to give that backdrop because it's this history of invention and innovation which stemmed from our manufacturing roots that has served as the raw natural resource of our time for this next industrial revolution. It was leaders from Westinghouse which had a vision and helped form the Carnegie Mellon University Robotics Institute in 1979. That was formed to conduct basic and applied research in robotics technologies relevant to industrial and societal tasks. Since that time, Pittsburgh has gone on to pioneer advanced robotics or autonomous systems. It has created the first robotics education and research centers, is credited with launching the autonomous vehicle industry, and today leads in developing talent and new commercial entities in this industry. Next slide, please. We have many of the world's leading engineers in a variety of key areas. Pittsburgh has a growing community of world-renowned roboticists across a wide array of R&D and commercial development areas. This ranges from field robotics study and deployment and testing to human-centered design to manipulation, sensing, perception, and AI. Individuals who have led major areas of research and who have helped create new industries and launch new companies are fairly well known in the industry, and I'll name a few here. And they're pictured on the slide. There's Red Whitaker, who is credited with launching the autonomous vehicle industry and is also pioneering autonomous space exploration. You have Marshall Hebert, another leader in autonomous land vehicles, which was the precursor to the autonomous vehicle industry we see today. Marshall is also recognized as a leader in computer vision and is the current lead for CMU's Robotics Institute. There's Howie Choset, who sometimes is commonly known as the SnakeBot, which is a fairly impressive robotic system that's able to go into areas inaccessible to many machines, and who has founded companies in the areas of surgery, modular robots, and autonomous guided vehicles. Hans Moravec discovered occupancy grids, which is a method for robotic spatial representation, and who has considered the implications of evolving robotic intelligence in our society. And then finally, Brian Zaleski, who has worked on autonomous systems for mining, paint removal systems, and off-road mobile systems. Brian co-founded and now leads Argo AI, which partners with Ford and Volkswagen on autonomous vehicle development and market solutions. And there are many more people. And so as you come to visit Pittsburgh, we could be a connection to meeting these pioneers and those who are leaders in their field. Next slide, please. So today, the topic is about smart manufacturing and what robots are capable of doing and what might be possible in terms of new applications. If you look at the work that the Advanced Robotics Manufacturing Institute, or ARM Institute, one of our partners here in Pittsburgh, is investing in, you will see that we are leading advanced automation across manufacturing processes, from fabrication to finishing, assembly, inspection, and material handling, selection, and transport. Autonomous systems and artificial intelligence-driven technology promises to touch every facet of manufacturing. And what this can do for your companies and for our industry is to address growing labor shortages that we see across a number of industries, and is also a worldwide problem today. They will also help expand customization and personalization in the products that you build and that go to market. They also can bring manufacturing closer to markets in a more decentralized manner. And then finally, these technologies promise to improve scale, efficiency, safety, and profitability. You can see here all the sub-processes where innovation is occurring, from molding to casting, folding and bending, sanding, grinding, polishing, sticking, gluing, and bolting, to inspection, and ultimately the material handling of the raw inputs, and then the takeaway of the finished goods or finished products. Next slide, please. You also see here small glimpses in the images of the mobile bases and the smart industrial robots, advanced manipulation techniques, grasping, and handling of items, many of which today are fully autonomous, and also are being designed at this time to be collaborative in nature, working alongside human operators. Up until this point, many of these machines worked with prescribed tasks that were programmed into the system, and they were really just working along limited axes to perform specific tasks in a precise nature in a reliable way. Next slide, please. The key technologies which are driving these new solutions include the following in this slide, and I'll review these just briefly. Human robot and robot to robot interaction. And this is necessary to create improved interfaces and to ensure safe human collaboration within our manufacturing facilities. We're developing intelligence systems based upon artificial intelligence and machine learning techniques for autonomous mobility and manipulation. This allows advanced cognition, decision-making, and intelligent actions. So we may have more acute and precise levels of perception and situation awareness in order to provide, to perform higher order tasks faster, more accurately, and with greater precision. With a lot of the hardware innovations, we also see dexterous maneuver and manipulation innovations. All of these techniques listed here are necessary to make robots more mobile, more flexible, and to perform a higher range of tasks. Our innovators are working on reconfigurable design, which ultimately will lower the cost and complexity of the system and also help with higher adoption rates. And then finally, there's work happening in modeling, testing, and evaluation tools to improve the implementation and the maintenance of these systems. We here in Pittsburgh, Pennsylvania, in the United States, spend most of our time on developing advanced systems to solve these incredibly difficult challenges in manufacturing. But we look forward to discussing these applications with you further so we can better understand your needs and your requirements to develop viable applications for well-known use cases. Next slide, please. So in Pittsburgh alone, this research and innovation has translated to over 100 commercial organizations who are driving innovation and changing the world. Again, I mentioned it before, we are changing the way we work, with the way we move, and the way we live. And this does include moving the supply chain along more efficiently, performing industrial inspections, creating digital twins for design, simulation, and testing and engineering, architecture and manufacturing, and other key manufacturing applications. But in Pittsburgh, I also want to mention that we're helping feed the world with agricultural robots. We're going to the moon in aerospace and space exploration. We're driving hands-free with self-driving vehicles, working in retail, improving lives with exoskeleton solutions and robotic prosthetics. And we're also saving lives through surgical robots. Next slide, please. I wanted to show this slide mostly as an invitation for you to come visit us. Pittsburgh is known for its three rivers, and the banks of these rivers were home and supported a past industrial revolution. Many of our robotic companies and commercial businesses now reside in a densely concentrated stretch of land along the Allegheny River that is known as Robotics Row. We look forward to hosting you to make new connections and to develop new business relationships. Perhaps some of you may even consider setting up operations in or around this area so we can have closer industry collaborations. Next slide, please. So in closing, the PRN exists to bridge the Pittsburgh robotics community and artificial intelligence community with other worldwide robotic communities. It is our collective mission that together we accelerate the adoption of autonomous solutions that will benefit us all. Whether you're a user of automation solutions, a global supplier or integrator, someone looking for a career in robotics, or an investor seeking an investment in this growing field of robotics and AI, our organization exists to promote your business within our network, connect you to one of our companies or key stakeholders at one of our programs or in-person events, and to work with us to help influence the overall direction of the industry. We're very thankful to sign this MOU today. We thank everybody for partnering with us, and we look forward to prosperous opportunities ahead. Thank you very much.
Thank you very much to Joel Reed, Executive Director of PRN, and thank you very much for what you do. And we will definitely try our best to keep this collaborative relationship going. And thank you again, ladies and gentlemen. We right now move on to the second keynote talk today. Our speaker is Mr. Charles Tam, Country Manager of Rockwell Automation Taiwan. He is responsible for leading sales, marketing, channels, business units, operation, and overall Taiwan and Hong Kong business. And prior to Rockwell, he also held important positions at GE and also Foxconn. Today, he's going to talk about advanced manufacturing and business opportunities. So over to our second speaker today, Mr. Charles Tam.
Hello. Hello, everyone. Yes, okay. Hi. Good morning, everyone. My name is Charles from Rockwell Automations. Today, my topic is advanced manufacturing and business opportunities. Okay, so let's move on for the first slide. So I believe a lot of people have been heard about Industrial 4.0. So in my experience, I have 20 years experience in this industry, for work for different customers. They asked me to talk about like Industrial 4.0, digital transformations. It was a very hot topic in last 20 years. And I would say in last 2-3 years, something is changing, especially like the COVID-19. A lot of my customers talk to me, they would like more remote monitoring, remote operations. And at the same time, I could see is a very big change for my customer. They are move on not just Industrial 4.0. They are telling me they don't want just a single platform, standard platform. They want something for them to make in industry for their company or for a factory, have a custom-made solutions. There's a lot of custom-made applications, custom-made solutions, particular for their factory or for their industry. It's a very common questions for me, and I can see that's the trend is moving on. I don't know is it Industrial 5.0 or not, but I definitely see there's a big change going on in the market. Okay, next slide, please. So from my experience, I can see every time a lot of people talk to me, different manufacturers talk to me, what is the challenge to move on to the digital transformations? I normally give them 4 challenges. First, is a very common challenge everywhere, especially in Asia or Taiwan, the capacities. Why? Because in the factory, I can see there's always have different level of different age of machines, different generations, maybe from 30 years ago, 10 years ago, or even some new machines have different control system, some even obsoleted. And it caused a lot of trouble because no one can get the data from it or no one can know how to modify it. So it makes everything complicated and is a very common challenge for a lot of manufacturers. Second, connectivities. A lot of factory, they already have a basic automation system, control system. However, they cannot get the data. They cannot, through the lab work, to get the real-time data, to do the dashboard and see what is happening. It is a very common, they have a stand-alone machine, stand-alone production line, and never connected. And then another challenge will be when even they can produce a dashboard or a report, they cannot act the problem quickly. Say, particular production line done, particular chiller or particular motor done. They don't know how to react immediately and maintain the productions. So it's also a very big challenge for a lot of manufacturers. The last is very common for a lot of global manufacturers. They may be very successful in a particular production line or particular machines or particular factories. However, once they want to scale up to another new factory or another country to build a new plant, new site, they always face challenge because they don't know how to scale it up, how to repeat the successful story in the original country to move on to other countries. It's a very common challenge for the manufacturers. Next slide, please. Next slide, please. Okay. Yep. Oh, sorry. Can you go back to the slide before? I think time delay in here. Okay. Yep. That's okay. So in industrial automations, not just the 4 challenges I mentioned it, but a very common nowadays is about the data. I can see a lot of my customer or a manufacturer, they have a lot of experienced people. They make the decisions depend on particular engineer or particular team to base on their experience to solve the problem. At the same time, I also see the challenge for them is because they always based on experience. Maybe if the engineer left the company, changed the job, or even retired, they're facing trouble to have this kind of data analysis. They don't know what to do next. Also, the common problem will be even they can get a lot of data, but normally stay in a single machine or a single production line. They don't have any interactions between different production line or different machines. So all the data, they have a bunch of data, but they don't know how to analyze. So the problem is how to do a smart data. Without this kind of smart data, they cannot move to have a proactive solutions to solve the problem, to predict the problem. So that is a very common situation nowadays. I can see almost all my customers have this facing the same situations. So next slide, please. Okay. Normally, when I be a consultant to visit different manufacturer, I will put them in different level. First, of course, even some of my situation is they even have no computers or control system for the machines, very human orientated. And some maybe they have a very mature control system, but not connected together, maybe due to different brand of control system, different platform. They cannot integrate. They cannot pull out the data from different generation of the machines or production line. So that's why they cannot do the next level is the dashboard. A lot of decision maker is really based on the data connected, have a dashboard to know what is happening in the plant. This is very important because the situation, if they don't have the dashboard alarm to the decision maker, they don't know how to make the decisions. So there's a 3 level I always can see in Asia or even in Taiwan. It's very common. The first 3 level, most of the people stuck in the first 3 level. And some even better, I can see some is better, is not just they can show the dashboard, but also is they understand why it's happening, why something goes wrong. They understand, oh, it's come from the motor or particular system. So they understand how it goes. It's much better step, which is to break through it. So some manufacturer, they are even better. They can do is they even can predict what's happening in the next stage. For example, some of my customers, they can tell the decision maker, particular production line or particular motor, they may go down fail in 2 days later or 2 weeks later, so that they can prepare in advance to tell the decision maker or the owner, we need to prepare the spare part or do something change to minimize the impact for the productions. That is very good solutions. Not many can do it, but I can see a lot of manufacturer is moving on this path. The last one, I would say the best solutions, a very mature level for the digital transformation is for they not just can know what's happening in the plant, they also know where the problem comes from. They also can predict what happened in the futures. At the same time, they can provide solutions to automatically to solve all the challenge or any problem may happen in the futures. Say example, they predict one of the motor maybe goes wrong in another 10 hours. So they have well-prepared spare part from the supply chain, and then they can minimize the downtime, or they even very smart maintain the same output, but just swap with all the production procedures and maintain all the output without nothing impact. That will be a very, very mature digital transformation or smart manufacturing solutions. Okay. So next slide, please. I would say how to be the winner for the future manufacturer. That's always my question in my mind. And I would summarize into 3 parts. First, skilled worker. It's not just a Taiwan problem. Actually, in global, a lot of country lack of good worker, skilled worker, or engineer. So of course, it's one of the core components if you want to be a smart manufacturing. I will elaborate more about the skilled worker in the next 2 slides, but the second core important about smart manufacturing is the IT/OT integrations. I would say more than 90% of what I observed in the manufacturer, they have problem about the IT/OT integrations. They normally have different team, not always talk to each other, different system, different data, different protocol. And when have problem come out, they cannot cooperate together to find the solutions. And even 2 teams may fight with each other. This is a core problem or core challenge for a lot of manufacturers. So this is a basic. If you cannot go on to the IT/OT integrations, it always is really hard to move on to the future for smart manufacturing. The last part, but not the least, is nowadays is very common topic in a lot of manufacturers. even though they have invested a lot for the smart manufacturing, the top grade control system, top grade software platform. However, if they don't concern or they don't focus in the site security, safety, is always cause them a lot of trouble. For example, cybersecurity is a very hot topic right now for a lot of the manufacturer, because they lack of experience for that, and they don't know how to, and lost a lot of money. So I would say, in summary, if you want to be a winner for the smart manufacturing in the future, these 3 points will be the most important. Slide, please. So I did mention about the workforce or the worker skill. A lot of people think the engineer or worker, the most important for the factory is they know the domain expert. They know the process, they know the industry, they know their plant very well, and they know the production very well. That's true. However, if you want to move on to the smart manufacturing, one knowledge is not enough. You also need to know industrial automations. If no automation knows that, they don't know how to optimize the whole productions. At the same time, the other core component is with the data processing. Nowadays, a lot of data that can connect it, but they don't know how to do it smartly. It is now, that's the challenge for the world manufacturing, is how to combine these 3 skills of people together. Not just domain knowledge, not just automations, but also data processing. From my experience, say myself, I have more than 20 years for the industrial automations. However, I have no much idea about data processing. It's a really, really hot topic for me. So to solve this problem, it always cannot say I hire more people, different people to combine together, because as I mentioned, that the skilled worker is very limited in the market. All your competitors or different industry is getting different kind of talent in the market. So what I would say to do is next slide. Normally, I will tell my customer or manufacturer is you cannot just depend on the engineer or particular engineer. You need to equip them. You need to build tools for them. So they maybe only have the knowledge for the automation. They maybe only have knowledge of the domain experts for particular process. The problem, the solution is you need to find a platform, build tools for them to minimize human being orientated. Not just depends on particular engineer, but also depends on a platform. A standard platform help you to let the decision maker make the right decisions. Or even though once this platform build up, with the empowered the worker to get all the data with the right decisions, you can move on, like improve your factory OEE efficiencies, or even make a new product, or how to minimize downtime. That is a very big solutions for a lot of companies. That's why we think is how to equip them, how to give a choose a platform to not just depend on a particular employee, but a very advanced platform to help them to make the decisions. It is all the core about the digital transformations. Coming up, I have 3 more examples would like to show everyone. Is about through this, in this stage for digital transformations, the business opportunities. Those are very common opportunities, what I observed in past 10 or even 2-3 years. A lot of, almost all manufacturers, they are looking for that. Please move on to the next slide. So customer experience enhancement, which is a very common topic, not just in last 5 years, maybe or last 20 years. A lot of manufacturers, they would like to improve their product, their end product. They want to give a better experience to their customer. They would like to say, auto industry, they make the car, they would like to know anything goes wrong or any complaint from the customer, they can immediately know which part of the car have problem, when they manufacture the car, which component goes wrong, which supplier for that component, when they do the assembly, which batch of the component or supplier they do the car, they make the car. So it is a kind of in IT OT integrations and a chunk of data to have a platform to analysis. So I would say it's a very a lot of customer or manufacturer, they are very focused on that to do that. Not just in auto, but maybe in tire industry, maybe in chemical industry, or even semiconductor industry. They are very hot topic. How to find out the root cause. Without finding out the root cause, they don't know how to improve the overall product. They cannot improve the competitiveness with their competitors. So it, or even faster to the market. They want to avoid the recall for the product. They don't want to, they want to improve the quality. Is a very hot topic. I think in last 20 years or even 10 years, everyone is looking for that. So it's a very typical solution opportunity for a lot of manufacturers. So next slide, please. Energy is a very hot topic, especially in the green energy. So I would say especially in the 5-10 years, almost all the manufacturers talk about that. Even in Taiwan, nowadays, they are not just solely relying on the public utility power supply. They may have their own green power production system, say solar energy, say wind turbine. A lot of factories, they want to have alternative source. So once they have this alternative source of the power or energies, they need not just act on it, they need to have a platform to analyze how and when is the best timing to use which kind of energies and how to storage. Maybe they should turn on the wind turbine or solar machines in the daytime, or when they swap the production, how to minimize the power or energy saving is almost a lot of hot topic, not just in Taiwan, but everywhere in the world. And to do that is a very complicated solutions. You are not just need to know the whole process of your plant, understand all the automation system, but at the same time, you need a platform to help you to analyze the data. When is the best timing? In winter, maybe we need to change particular chiller to on. In summer, maybe another story. The other kind of chiller they need to turn on. So it's a complicated solutions, and energy optimization, again, is a very hot topic, and they are move on a lot of opportunity in this area. Last, can you please next slide? Due to COVID-19, this is a extremely hot topic, and based on the AR technologies, a lot of my customers, especially a lot of Taiwan export machine builder, they send a lot of machine to the States or to other countries, but due to COVID, they are not willing to go to the site to do it, and even it's take a lot of time. So due to use a combination of the AR technologies and the software platform, now the customer or the machine builder, they don't need to go to the end user site. They just can sit down in the office room in Taiwan, and then with the real-time communications with the AR technologies help, they can do the maintenance or emergency repair by themselves, or remotely to talk with the customer. At the same time, not just emergency repair, but also like training. They don't need to send people to other countries for training. They can stay in Taiwan for training, or even helping them to do the maintenance or operations. So it is a very hot topic, especially in COVID-19. And I also don't think I think after COVID-19 is a very good, is a very common trending. I think this opportunity will even more after COVID-19, because not just because of the time saving, but but also cost saving. So today is all my sharing. Thank you very much, everyone. Thank you. Hope you enjoy it.
Thank you very much to Charles Tam for sharing with us so much about how it's done at Rockwell. Ladies and gentlemen, we are going to move on to our next talk. Our speaker is Mr. Robert Chen, Country Manager of Epicor Software Corporation. And Robert has more than 20 years experience in software development and business. And prior to Epicor, he has also led a variety of important projects at other leading companies in the industry, including Infor Global Solutions, SAP Taiwan, and also Franco Taiwan. And now to talk about digital transformation plus AI innovation application, let's welcome Mr. Robert Chen.
Thank you. This is Robert Chen for Epicor Taiwan. I'm the country manager for Epicor. And let me take a few minutes to introduce Epicor to you. Epicor is an leading software company based in US, and we are dedicated in manufacturing territory. And Epicor also known as the leading software for the ERP and MES, also called IoT, or now we are moving to AIoT as well. I will take the next 20 minutes to introduce our observations regarding the Taiwan and the manufacturing trend and how we can move up in this COVID situation. So next slide, please. Here's a statement. It's from the Boston Consulting Group. It says the companies that have purposefully developed capability to tackle ambiguity and unpredictability are most likely to thrive. And it's all about the. I think this is all about the COVID since the pandemic started, and now we are all suffering, or now we are moving to thrive, or able to gain more insight from this situation. So next slide, please. I forgot one important thing that I need to address. I would like to thank AIT especially because AIT has been Epicor's partners and clients for almost 20 years. And thank you, AIT. You are our faithful partners. And while the BCG also state that there are three phases that we can get through the pandemic, and the first one will be the response, and now I think we are moving to the third phase, while the vaccination is more applied to the public. So it's all about how we foresee and how we adapt the new era, or we call it the new normal. Personally, I prefer we call it new now. How we can moving forward from the past experience, especially for those several months that Taiwan have been encountered more severe COVID cases. Next slide, please. Epicor have an white paper talking about a manufacturing trend shaping for 2021. and it's all about the digital transformation. And let me share one experience, my success story here in Taiwan. We have been called out for a customer who is making the surfing board, and in Nantou, which is near the sea. And funny thing is they reached Epicor for they want to have more capability in e-commerce that make their customers or their distributor to place order more easily. And when they reached me, and I stopped by and looking around and take a tour in their factories, and we found that it won't be their major issue. Although the chairman have built the automation warehouse, even have RFID in place. However, we found their basic process, the infrastructure, the information flow are independent or silos, or it's not integrated at all. So even we can help them to have a better e-commerce or online quoting, online ordering system, but in the end, they still cannot fulfill the order or the needs from their customer. So we recommend them that they need to streamline their internal process. And finally, they went live, and they got benefits from the very beginning, from the ordering, taking to all the end to the finance systems. Next slide, please. Here's one example. In the past few, actually in the past 2 years, I've been in Taiwan, serving some auto parts manufacturers, and they all provide the parts for the for Tesla, and which is good. So here's another example. We are helping the London EV, which is London Electronic Vehicle Company, to help them to make their operation more efficiency. I apologize, I cannot hear the video, so I saw the video already on. So do you think you can start it again? Thank you. It's a 2 minutes video. So please play it. Thank you.
...7,000 square meters. At full production, we'll be producing about 20,000 vehicles per year. The vehicle consists of over 2,000 components from 200 suppliers from the UK, Europe and China, all delivered and configured to order. Our IT infrastructure consists of over 120 kilometres of structured cabling, 14 kilometres of fibre, with over 100 network switches and Wi-Fi access points, all sitting on top of a high availability virtual server and network environment. My team of 15 people are responsible for all the information systems and the core technologies relied upon within the factory. Everything from booking meeting rooms to networking, from access control systems to interfacing with all the PLCs on the shop floor, including the flashing of the software onto the vehicle, and of course, Epicor, our ERP system. Having shop floor fixtures and connected systems
there's some important things regarding the digital transformation. Let me share some more experience or some stories that I observed in Taiwan. As I mentioned earlier, I have helped some auto part manufacturers in the past few years, and they really took good very well while they are in their daily operation, especially in running the manufacturing. And however, they also encounter more and more challenges. Some of the challenges will be like they are asked to provide more some small amounts, but more custom products, and they all can deliver it. But however, it's not the past experience that the past experience will be like a mass operation. But now the Taiwanese company are really good at, I think Taiwanese companies have the advantage, especially flexible production manufacturing in produce small amount but custom products, and even have flexibility to do the make to order scenario, and which help the Taiwanese company really perform well in the global market. So while they are reaching me, they all want to have more insights and more, they want to have benefit from their information system, the intelligent property regarding their data. Those data are also silos or broken or not integrated, cannot reveal their, cannot help them to fulfill their goals. So back to the digital transformation, and they, especially during this pandemic time, and the global the global economic, such as the trade war between U.S. and China, and this all infect our Taiwanese company for their coming plans in the futures. And next slide, please. I didn't. There's one thing that Epicor doing well while we serving the Taiwanese company, that we not only introduce then the new technology, the software platform, but we also help them to have the brand new mindset, which is called lean manufacturing. Lean manufacturing is a known term in Taiwan at least 20 years as well, but we are not introducing the lean manufacturing. We are introducing the lean management, and how the lean management can help our Taiwanese company to eliminate those waste due in every perspectives. While we introduce lean manufacturing, there are two key components that we share to the Taiwanese company, and which is why Epicor is doing very well in the U.S. Not only in U.S. Actually, this October is our Epicor financial beginning, the new financial year, and we just review our finance data, our outcome, our performance last year, and we all achieve, not only in US but also globally, we achieve our finance goal, And this is a good news for us, even in such difficult times, and we still make our numbers and show the world that all the company are back to business. And while during this period of time, we are talking resilience, and there are 6 dimensions that Epicor can help our partners, our clients, or the Taiwanese company, like they can leverage it to make a successful future. The first one would be the protect and grow the top line, which is go back to the competency, the advantage. Just like I said, we see the Taiwan companies are good at the flexibility in make to order in small amount of manufacturing, which are the core competency for the Taiwanese company. The second one will be developing the agile operation, and which is why we introduced the lean manufacturing, lean management to all the companies, that they help them to eliminate at lowest waste during their process, and even for their mindset, that they can leverage it to have a better management. And the third one is enable people. I think the Charles Tan has addressed this a lot already. And the fourth one will be the accelerate the data and digital platform, which is Epicor are good at. I usually call Epicor as a robotic transformer, and because Epicor's leading technology that help our customer with lower cost, but can benefit from the IT infrastructure to have to get more insights of their daily operation. The first one is the cybersecurity, which is quite important, so I won't address here. And the sixth one, the last one, will be the strength, the finance, which is the foundation of an company, how they can cut cost, but with equip it, the knowledge, the people, the facility, I can then move to next arrow. My next slide, please. Here is also talking about the 6 dimensions regarding how we survive and even thrive, or can be prosperous in the coming futures. So again, the first one will be the protect and go the top line, and this is what we are doing here, and help the Taiwanese company to help them to sustain and to build their core competence, and with IT leading technology, build a platform and help them can be more competitive in the market. And I would like to talk about more develop the agile operation. That we always think that the Taiwanese company are really flexible, but somehow we understand they are not. Somehow they are not collect necessary data or integrated data together to have them and insight of their business, and how they can manage their business well. So which is why mention again the lean management. There's one example we share to our customer. We said there's a key mindset regarding lean is that there's no KPI within the company. I didn't mean there's no KPI. I mean no KPI for each department within the companies. So one example is that the sales department have met their number and got a lot of orders. However, the manufacturing department or the procurement department cannot fulfill it. So in the end, the company didn't benefit the big order, but they are suffering internally for their operation or their supply chain. So while we introduce this KPI, then we help the client to become one single team to pursue the one single goal, which is get the benefit, which is margin of their business. So it's interesting. Even we apply some we develop some activity, some social network activity to help them to understand how the lean management can help them, how just one KPI, and I mean not really one KPI, but a KPI for one single company can really help them, but take away all the department KPIs. And I think this should be my last slide. So thank you very much. And the last slide will be the Epicor. We are 50 years company in 115 countries, and we are dedicated in software, and our revenue is $1 billion, and this past year we over 1 billion as well. So thank you very much. Thank you for your time.
Thank you very much to Mr. Robert Chen from Epicor. Our next speaker is going to talk about how to integrate AI with digital manufacturing. Let me introduce to you your next speaker, Jiantan Lian, Chief Technology Officer of Industrial Automation Business Group, Delta Electronics. He joined Delta back in 2016 to share his 35 years experience and know-how in industrial automation. And he vowed to give clients the best services possible with cutting-edge technologies. And now, without further ado, please welcome your next speaker, Mr. Jiantan Lian.
Thank you, everyone. This is Jiantan Lian. I'm with Delta Industrial Automation Business Unit. I'm happy to join this summit. Actually, most of the speakers have a one way or another relationship. Joe from Pittsburgh. I used to live in Cincinnati for 20 years. I went to Seven Springs for skiing vacation, which I enjoyed that. And I was with Rockwell Automation till 2009. And my ex-boss, Kevin Roach, was VP of Epicor. And Professor Jay Lee, we met each other 20 years ago when Rockwell acquired Entech, which is a predictive maintenance software company. So happy to meet everyone. Today, I'd like to share the experience from the AI emerging with digital manufacturing, and also our vision. I'm going to talk from a mega trend, and then how to do digital transformation, and how to embrace in AI, and our vision for future intelligent manufacturing plants. Next slide, please. For mega trend, let's look at the year 2000 and before. There was a PC booming stage. or the computing technology start to grow, if everybody remember, there was a millennium bug in the software called Y2K. At the year 2000, the year will get reset to 1900. And I remember some of my friends even bought water and get cashes from ATM and try to stay away from this disaster. And luckily, there was nothing really major happened, and we all went through that okay. But the next year computer software year problem is coming up. Well, 17 years later, it's in the 2038, January 19, in Linux system and Unix. So that's still 17 years away. I guess let younger people to deal with that, but we should start to thinking about how to resolve that, because most of the industrial equipment now it's under Linux system. And every 10 years, you can see the mega trend. Every 10 years, there's some technology booming. In mobile phone in 2010, Nokia and Motorola dominate the entire phone market until Apple, 2007, coming out with the first iPhone, which turned in entire industry upside down. And that's what we so-called smartphone, and we continue to use that. And now we're looking into the autonomy era. Everything goes to autonomous. And this is the future we have to deal with. iRobot coming out with the first Roomba vacuum machine in 2002. I remember I bought one, and it was nice. It cleaned out your floors on time and just return to charging station automatically. Everything is so great. So I brought it to the second floor to start to vacuum. And guess what? It fell down the stairs, committed suicide. Because at that time, the technology forgot to detect there's a stair. And nowadays, all the vacuum robots, they all can detect the stairs to avoid this tragedy from happening. Now, same thing goes to autonomous. There's a lot of areas we have to be careful to deal with. And I believe in the future, we will move into autonomous manufacturing. Next slide, please. So Industrial 4.0, it was coming out from Germany, and everybody moved into that. The core focus for that is digital information. Everything goes to digital. And we can see from Foxconn lights out factory, you can see Philips has a factory produce razors, totally no man. So Nuke Robotics, start from 2011, it's totally lights out. And so that's our focus toward to the future. And I believe metaverse, the buzzword we are talking today, will be in manufacturing very soon. Next slide, please. Next slide, please. Yes. So let's talk about the pain points for the manufacturing. Today we're still very labor-intensive business, and in Taiwan we even import labor for our facilities. And we're still focusing on centralized manufacturing because all the supply chain around us and can produce an even lower cost of goods. COVID in the last 2 years impact us a lot. If a COVID goes into one of the factories, that factory has to shut down for a month and produce nothing. So that's, we don't like it. Of course, trade war, that goes to global. So manufacturer has to think about how to reposition in the future. And going to digital is one way to survive. With the technology intensive, we can use all the knowledge we have to build a smarter machine. And instead of centralized manufacturing, we can go distributed manufacturing. And that's how we are going to lay out how we're going to going around the globe and see where to set up your distributor facility for manufacture the goods. Of course, during manufacturing, we have to do very flexible in production. And business, if we cannot do resilient production, it will be out. Now, everything under cybersecurity. Like Charles says, cybersecurity is the key. And we cannot avoid that. If you remember that there was a .NET, a cybersecurity issue in Iran. And that was a hacker hacked into the Siemens PLC programming, which caused trouble. And when we try to prevent this security, we cannot just sit in the IT world. We have to also look into the OT world in order to avoid the entire security issue. Next slide, please. So when we talk about digital transformation, there are 3 steps to do that. One is integrate. We integrate all the machines together. Machine cannot be stand alone. It has to talk to each other to be able to commute. And then goes to digitization. And very important is how to put AI embedded in your machine and be able to produce your goods under good quality and under fast speed. And again, I want to mention this very key cybersecurity issue. Without this, all of our effort could be in vain. And customer want the product yesterday. So we have to more smart and build in our digital manufacturing. Next slide, please. So digitalization, talking about architecture design. In the factory, more than half still legacy machines, which cannot talk. And you cannot just trash them away. So how we make legacy machines smarter? That's the one design we have to deal with. We can make legacy machines listen, communicate with more advanced modern machines. And domain-driven, domain is also a key in the AI technology. If we just do AI without having the domain, it's useless. So for example, in the PDM business, predictive maintenance, we cannot treat machines with one solution, one PDM methodology to detect the machine failure. Machine failure like a human being. So we went to see a family doctor. Family doctor can solve almost any issues, but still there are some particular issues family doctor cannot solve and have to refer you to specialty. And each specialty is a different way to solve your sickness. Same as a machine. Machine health also could have a lot of failures. Now you have to know how to deal with each one in order to make it success. So digitalization is very complicated. And we have to keep our goals simple and doing in phases approaches. into the phases approaches and make it very simple so you can reach one goal and then look for the next one. Next slide, please. So embracing AI is the key. Like I said in the last slide, AI is not just a math. Yeah. A lot of people thinking about AI just deal with the probability and statistics. But in real, the AI not only from math, but also have to put your domain knowledge into it. And without having domain knowledge, AI cannot be used. And that is our key problem today in most of our manufacturers. We do not know how to put a domain know-how with AI together. Or we forgot about the domain know-how. We just believe AI can solve everything. So AI has to come with a domain know-how in order to make it very successful. Next slide, please. Next slide, please. Let me check. I don't know, I lost the camera. Okay. Now we're back. So AI deal with the harvest data. Everybody talk about big data. We have to use data properly. We have to collect the right data. Yes, they are correct. But one thing we have to avoid is the data bias. For example, there was a technology that can turn the photo from blur to more clear. So people run that with President Obama's photo. Take a little blur photo from Obama and run through this and come out with a clear photo. Guess what? That turned President Obama into the white. And that because of the data bias. All the training models are toward to the white. So when you come in to use this technology, it has a data bias. And that's where we have to avoid in our manufacturing AI as well. In the manufacturing, we do not use AI and say, hey, that's one problem and you have to deal with. And guess what? That problem, it couldn't be a problem if your data is wrong, it's not right. So AI, big data, you have to use the right data, and you have to continue to do optimization. Without doing so, it just comes with the equation. Next slide, please. So most of the AI application in our current factory is deal with the image process. We use the image to detect your product quality. And digital image can almost replace human eyes. Human eyes can only see 10 million colors, but computer can see more than 16 million colors. So a little tiny color changes, camera can detect that. And we all use that technology in our factory and to detect the quality problem for our goods. So for how to use that, it's very important. And again, digital image not only to use to detect the quality, it also can use to do other things. And here I make one simple example. This is not related to the manufacturing. It's with a digital image, you can extract human voice out of your image. And that's one of the techniques coming out from MIT. And I think in the future, that might get used in everywhere. Next slide, please. So we put in the 5G in the factory. And because of 5G latency and high speed, we can make our equipment, talk to equipment very fast and communicate very well without any interruption. So in our Delta factory, in one of our factories, we set up this 5G demo site. We utilize Microsoft and we partner with the PDC together to make it happen. Next slide, please. So visualization in the factory, once you digitize everything, you have to be able to visual to see your factory and be able to monitoring with the AR through your MR technology to see how your factory was running around the globe. Next slide, please. So finally, in our digitalization world, we transform from legacy machine. We use a smart design to make a smarter product, smarter machine, and we integrate AI and big data through remote monitoring, and even doing the energy management. Energy management is a key in our manufacturing floor. Through this carbon neutralization policy, we have to help our manufacturer to monitor how your energy get used. Next slide, please. So in Delta Electronics, we try to make machines smarter and we make Earth greener. We are totally committed to by 2030 for carbon neutrality. And let's work together for that. Thank you very much.
Thank you very much to CTO of Delta Electronics, Jian-Tan Lin, for the very informative talk. Ladies and gentlemen, our next speaker was selected as one of 20 most influential professors in smart manufacturing by SME of the US in 2020. And he is an expert in industrial big data, industrial AI, and Industry 4.0. Right now, he is a member of the board and vice chairman of Foxconn Technology Group and also Hon Hai Precision. Ladies and gentlemen, to talk about industrial AI and smart manufacturing, please welcome your next speaker, Dr. Jay Lee.
Can you hear me, Aaron?
Yes, we can hear you very clearly.
Okay.
Please.
Thank you. Okay, yeah. I think I will go over, I think most of the people have presented already different perspectives. So I will talk about some few stuff we have done, right? We have done many, many times. So the resilient manufacturing and how our industrial AI team we have developed over the years can help ourselves and help our customers and help the rest of the future community. So basically, I look at first what the issues of industrial resilience system and what we are facing today already, right? So we have a shortage of chips for many, many reasons, and not single one, no, many. But the industrial AI system we developed many years ago, Foxconn has adopted such a system. So we're building in the United States first and try to make our future a system globally connected and more productive. And I'll give some example. When New Board was formed 2019, New Board launched a Foxconn 1.0, 2.0, and 3.0. 1.0 is very simple speaking. Basically, look at ourselves in the back, find those weaknesses, improve it, right? It's like check our weakness and strength and make your strengths better, make weakness disappear. That's what we want to do. Foxconn 2.0 is really adopt a new digital platform, allow our business, procurement system, supply chain can truly with agility, velocity, and transparencies and traceability. And Foxconn 3.0, Foxconn is too big. We cannot just develop some products production. We have to have a scale. The CAGR have to go beyond 25% or higher. Otherwise, it's not worth it to do it. So we basically look at the EV platform and digital health, large scale, and robotics XYZ. We have some project we cannot talk about today for the robotics, but the AI, semiconductor, 5G, 6G, we all have that in US. But the semiconductor recently, a company made investment to invest in the silicon carbide, right? And eventually to make the inverter and also onboard charger for EV. So we call 3 future industry and 3 core technologies. Now, this is a plan. I'm currently in US, so this is a 2018, and groundbreaking, this is today, right? So we have invested over $900 million in Wisconsin. And so far, and our smart manufacturing center, the backlog, we have enough big backlog for several years. So, and we have high performance computing center and multi-purpose building and large scale and high-tech carrier. So this is a high performance computing center, and we build with a micro data center. Eventually, we're providing high performance computing and bring those capability into every manufacturing industry, right? So basically, we build a data highway for the future industry, for agriculture, for healthcare. And so this is a one of a kind, is a landmark. When you land the airport, after you pass Lake Michigan, you probably see the landmark. And now this is Area 1, about 1,000 acres. Area 2, Area 3 together, another about 1,700 acres. So together is about almost 3,000 acres. That's huge. I think September 30th, we announced in principle agreement to purchase Lordstown Motors in principle, still under the, a finalization. Basically, this is a old Chevrolet Cruze plant. And eventually, once the contract's finalized, then the Lordstown Motors still continue making endurance pickup truck. Eventually, the Fisker personal, electrical, automotive revolution here will be made here as well. Now, October 18th, Hon Hai Technology Day in Taiwan announced 3 models: C-Class in the upper left, E-Class lower left, and also T bus. Each of a different scale, different features. So obviously, this is something that's going to be happening and sooner than later. Now, let's look at the resilience system. Why we define this way? Resilience system really is about today, right? Our production system, our supply chain have to survive. And regardless what happened, right? Because the scale too big. We're talking about over $100 billion acquisition procurement a year. So we can smell which parts is more expensive, which part is a shortage, which part is changing cycle time, delivering time. So those smell, which is very important because those are big data. And we don't have to wait for Wall Street to tell us. But that's the scale. We have to dip into the space of a knowledge. So if you look at this chart, before COVID happened, we're trying to fight for efficiency. When COVID occurred, demand dropped. And supply chain, many people start changing, making different things. Then when people start coming back to work, slowly demand increase, but supply chain cannot catch up. Meantime, logistics, you cannot find drivers. When you cannot find a vehicle, then you cannot find ship, then you cannot find container, then you don't have time, worker to unload them. Eventually, the imbalance causes the problems. Not really shortage, it's an imbalance. With the fast changing of the making of chips globally, eventually, you will solve partial problem, but you'll create another overproduction problem. So because the geopolitical problem, pandemic problem, natural disaster problem, unknown. And the workforce. We're hiring people every week here, right? Very hard to hire. Very difficult to hire. It's a good thing about we have a low employment rate in Wisconsin, in US. The tough things that you just cannot find the right people. So eventually, you want to design such a system can prevent the issue of supplies, logistics, and in the future capacity. You also have to be able to how to deal with inconsistency of labor. This is typo here, I'm sorry. So eventually prevent unknown. For example, inconsistency of labor. When we hire people, we put them on job day one. We can guide them through how to do the work without going through extensive training. That's the system we designed to help very fast, quick turnaround workforce. Right? You hire today, tomorrow you're on the job. The system will teach you how to do it automatically. After you have done 10 times, you learn. After 20 times, you do better. After 30 times, you're much better. After 100 times, you're good. Of course, now we're talking about human ability. We actually, to some extent, we are very good at what we do. Our lean help us to deal with the problem we understood. Then eventually we have discipline help us to eventually solve the problem. But invisible problem, we never know what that is, right? Eventually we know what we know, we don't know what we don't know. Eventually, and we cannot solve. So those blue area is where really is about the limitation of human beings. Now, this area, if you're talking about intelligent systems, smart manufacturing, that's what it is. It's not about visible problems. It's about invisible problems. Right? So the industrial AI is a system which we've been working on for many years, right? Basically, you have lots of data from the machine, from machinery, from wind turbine, but a lot of people think, oh, I have a lot of useful data. So the company asked me to help. After 3 months, I went back to the CEO. I said, I'm sorry, your data is useful, but unfortunately, they are not usable. Why? Because you did not label the background properly when you collect them. The data is broken, data is bad. Bad, broken background, right? It's a 3B I'm talking about. So we need to evaluate why data can be useful, why data can be diagnosable, why data can be predictable. If you cannot predict the problem from the past, forget about predicting the future. It's dreaming. Nobody believes you. So industry system is not about just an algorithm. It's about actual implementation. So in AI is a cognitive science, can be anything you're talking about. I worked at NSF 7 years. We found so many AI research. Now it become hot. 20 years ago, it was hot. It broken again. When you overcook them, they will create a bubble. But only those people who can harvest the results will continue transforming. So the AI is a science, the trying error, the trying error. Today I give you 2 algorithms, 2 engineers, some same data problems, 2 different results. That's not acceptable. If I build jet engines, no, I cannot use it. I gotta have a systematic way to do it. Right? So this has been, I've been teaching worldwide in this subject. So basically, this is systematic discipline. So we have different algorithms that we select how based on the what requirements, what condition, what speed, what lack of a domain knowledge. And then we select different algorithms between random forest, between logistic regression, how you select the best. Again, I don't want to talk about here. So let's look at examples. Foxconn has Foxconn Industrial Internet and created 2018. And today the company, and it's about $70 billion. We connected over 175,000 machine tools, 80,000 robots we built by ourselves. 1,800 SMT lines, about equivalent to 12% of world capacity. So now when this machine are connected, we have the backbone of a data quality. So basically we're talking about scale of SMT, scale of robotic cells, scale of EVs we're going to be built. When those systems running around everywhere, are working everywhere, so we're building a system, we want to predict system. For example, this results. If you want to predict every robot for 2,000 robots in the factory, you cannot do it. So we have to find a new way to cluster them, evaluate the relationship to find the worst one, and then find the worst one. Then eventually, I can quickly identify the one I can predict almost 3 weeks before they fail. This is not a joke, right? It's real. Now, if you are talking about the future factory, worldwide, hundreds of factories, we cannot build every factory with their own people. We have to remotely monitor all the factories one day. So regardless of where you are, the platform has to work. So eventually, we develop a stream of quality methodology, trademarked worldwide. So based on the blockchain and the factory data, you come from each station assembly. You have different variations. We model them, we correlate them, right? Eventually, you can connect them to a same stream. When you look at the results of quality, I can backtrack which process step, which parameter was the main root cause of the good or bad. So for example, you have a packaging system from the classification of issues, you segment different type of a regime, you decompose different root cause, then you focus on the critical problems, then you share with the people they should know, you avoid issues before they happen, right? The systematic approach, step 1, 2, 3, 4, 5, 6. So by doing that, we had instrument a sites in 2018. January 2019, we got the first World Economic Forum Lighthouse Factory, and we reduced the 92% redundant labors. You don't have to waste your time, keep checking the machine. No, machine will tell you. So eventually, this is called Lights Out Factory, right? And now we have 5 WEF Lighthouse this year. Just September, announced another 3 sites. Foxconn 3 more sites, including in Analog in Taiwan. And this year, we will build 20 Lighthouse factory within Foxconn ourselves. Right. So, but that know-how going to become our service business for the world manufacturing industry. We don't just manufacture our product for customers. We also help manufacturing companies to do better manufacturing. So this is our book, the book I wrote, and it's published worldwide. And basically, we use the textbook to teach our engineers. Of course, in Taiwan, my previous book, and also there, if somebody interested, you can go get it. But again, most important things, we are hiring. Smart Manufacturing Leaders Program. We are growing, right? So we are focusing on talent pool. So eventually, not just economy, employment, but also education. I call 3E. Again, thank you very much. I hope this is a good overview of what we're doing. Thank you.
Thank you very much to Dr. Jay Lee from Foxconn. Okay, thank you once again to all of our keynote speakers for their wonderful talks. And now it's time for us to have more in-depth discussions. We now move on to the session of panel discussion. And let me introduce to you your moderator and also panel speakers. Our moderator is Mr. Stephen Su, Vice President and General Director of Industry Science and Technology International Strategy Center at Industrial Technology Research Institute, ITRI of Taiwan. He is also the CEO of TUSA. And joining us for the panel discussion, we have Guo Yisi, Chairman of Taiwan Automation Intelligence and Robotics Association, TAIROA, and also 4 of our previous keynote speakers, Jen-Tan Lien, Country Manager of Industrial, Jen-Tan Lien, the Chief Technology Officer of Industrial Automation Business Group of Delta Electronics, and also, of course, Dr. Jay Lee from Foxconn Technology Group and also Hong Hai Technology. And also online with us, we also have Mr. Joe Rhee, Executive Director of Pittsburgh Robotics Network. So over to our moderator right now, Stephen.
Good morning and good evening. This is Stephen Su from TUSA and also from ITRI, my organization. It is my honor to host this panel, and with many of you have shared a lot of insight just now. And so with The topic being Taiwan-US smart manufacturing collaboration, especially with Pittsburgh and the Pennsylvania state as the focus. The panel would go by 2 rounds, and the first round will be individualized questions for each of the panelists. And the second round sorry, there's a little bit audio interruption here. Okay, so let me continue. And the first round will be individual questions for each of the speaker and panelists. And the second round, I would like to ask a common question that is about opportunities and challenges for collaborations between Taiwan and Pittsburgh ecosystems. But to start with, I'd like to give a big thank you to US for the vaccination donation in the past few months, as well as to many other countries helping Taiwan. Thank you very much for helping Taiwan to be part of the global ecosystem. So the order of my question to the panelists will be slightly different from the order of the speaker just now. So please bear with me. So the first question go to Chairman Si from TAIROA. So thank you very much for your support on this MOU, and since you are a highly reputable expert on robotic and smart manufacturing industry, so based on your observation for Taiwan to march toward digitization, what do you see as the most important elements or lacking elements, and any suggestions to help the Taiwan industry move toward digital transformation?
Thank you for your introduction. So I think the digital transformation, particularly for a lot of small medium enterprise here in Taiwan, is indeed a top priority now. And during a lot of our engagement with the SME here in Taiwan, so we observe there are 3 needs. The number one is I think the robotic automation, Mr. Tam, and just in his presentation, he mentions skill, the manpower. The first need is we need more trained engineers. This is the first need. And the second need is we need more qualified system integrators for the help. And the third, number 3, is for this transformation, the cost must be affordable, because we have a lot of small, medium companies here in Taiwan for this kind of transformation. Talking about the number 1 need, manpower. So I think right now our government and also a lot of industry association here in Taiwan, and the support, finance, a lot of large-scale on-job training program. This is so that we have a more skillful engineer here, and also our government and supported more tighter academic and industry cooperation, and so that the graduate student, have how to earlier on understand what the industry need and what kind of skill they require. So this is the number 1 need. For number 2, about the system integrator, we need more system and qualified system integrator. So take for example, TAIROA, our association, and we established a so-called SI, System Integrator area here in Taiwan, so that we create a kind of platform for this system integrator to share their experiment, business matching, and also provided an opportunity for business development. This is one of the very important platform, so that the system integrator here in Taiwan can work together to meet this kind of need. And the number three need is talking about affordable costs for the upgrade. So again, our government, take for example, Minister of Economy, and also supported a lot of kind of program, research program, and development, and to support the company and also university to development the key component for smart manufacturing. And take for example, sensor and component for the robotic, etc. So that we can support a more deeper vertical integration here in Taiwan, so that reduce the cost for the upgrade. But I mentioned there's three measurements, but there is the other, maybe more faster way to solve this issue. One of these is, take for example, how can we use international resource more smartly? I think this is also important. Take for example, Taiwan-US Corporation. How can we go through the international cooperation to close the gap more quickly? I think this is also for today's the event. So that is my answer to your question. Thank you.
Okay, thank you, Chairman Si, for your outline of the three capabilities needed by the SMEs. And indeed, SMEs are the most vital in the Taiwan ecosystem, next to some of the big conglomerates such as Foxconn. And in fact, that we are encouraging many solution providers to help our SMEs, not just in manufacturing, but also in the service industry. My next question is going to go to Vice Chairman JD. And Jay is a longtime friend of mine, and also Itri. And I remember many years ago, Jay, you shared with me about predictive maintenance by detecting audio from the airplane engine. That was many years ago, way before people talking about AI. And very similar question about the key capabilities for Taiwan industries moving towards digital transformation. I'd like to focus a little bit in terms of Foxconn's partners, manufacturing partners, either in Taiwan or now moving into the States or developed from the States. What do you see as the most urgent requirements for their digital transformation, not just Foxconn, as you have presented many events, digital transformation initiatives within Foxconn?
I think first, let's look at the first question. Right? Digital transformation is not the beauty contest, right? Obviously, it's a self examination. So basically, every company, you should look at your problems, gaps. You look at the mirror yourself, find out whether your button is not good, and maybe there's a dirt on your shirt, your hair is not nice. Find the problems. But how do you find a problem? Well, there's all kinds of problems. The scale, the frequency, but you're trying to identify the frequency versus criticality. Identify those critical ones, and then select a good baseline of issue. So again, the first step is to find the problems. Examine yourself using data. You cannot just look at the yourself to find problem. No, get data, right? Then first, starting from the most critical issue and the low-hanging fruits. The second, the bottom line. You're gonna have a purpose. People don't do Internet of Things for Internet of Things. You don't do AI for AI. You don't do a smart thing for smart thing. You do smart things for the purpose. Purpose means quality, efficiency, right? Whatever you define, that's the purpose. From the purpose, you drive back the process, right? It's not the process, it's purpose, right? The bottom line. Number three, you have to make a compelling stories, fast line, because you have to drive yourself and eventually tell your partner and your collaborators, you are the best of what, right? But you have to believe, and you have to truly deliver what you do what you tell people, right? So eventually what we are looking for is that we have a clear business and element already. For example, the EV system, and my H platform is clear. So in EV system, we're not just make EV, but also we'll start developing a lot of software stuff, right? And for the EV's ecosystem, for example, battery system, and we're doing the services, we're doing the future life cycle, we're doing lots of testing eventually, and even the recycling. So there's a lot of chains connect to it. So certainly from that EV ecosystem, there are many, many opportunities. But of course, then in the digital infrastructure, we build many different digital electronics, high performance computing, and there are many companies, right, that they ask for that kind of things. But certainly the data have to be given from somewhere. Eventually, we have to work with company to create that stream of a data computing system. So we certainly are interested in hosting people to visit us, right, in the US. Of course, in Taiwan, you can visit headquarters easily, but in US, you can visit us in southeast part of Wisconsin, which is only 1 hour from Chicago O'Hare Airport, right? So our distance is actually only less than 1 hour, just like San Jose to San Francisco Airport. Our location just to about 1 hour to Chicago Airport. So you can visit us. We can share with you what kind of opportunities, and we can collaborate. Yeah.
Okay. All right. Thank you, Jay. Talking about the data being the first priority in building this digital transformation. Okay. The next question will be going to Joe Reed, the Executive Director of PRN. And in your presentation that you have mentioned that Pittsburgh has moved from coal, steel, and now the smart manufacturing with the AI and robotics being your strength in the area. And so my question is that, can you further elaborate how Taiwan industry can take advantage of these trends from Pittsburgh for collaboration such as digital transformation, and what are your strategies in facilitating the connection to the global market, not just Taiwan, yeah, for us to learn as well, yeah.
Okay, thank you very much. And again, I appreciate everybody's interest, and we do look forward to creating some of these new connections. So I've mentioned our technical leadership, and many people are familiar with the strength and worldwide leadership from Carnegie Mellon University. But we found, 5 or 10 years ago that we actually, we're not having the same success on a commercial side. So we generated a lot of, initial intellectual property, developing patents, a lot of fundamental research. And we were translating some of that technology out of the university, but not necessarily seeing the commercial success that you might expect. In fact, it was about, 1/4 of, when we compare economic output to intellectual property development in our community. And this is the backdrop by which the Pittsburgh Robotics Network was born. It was created by early stage leaders and a number of growth stage leaders as well. And they realized that there was a gap in our community in terms of commercial understanding. This panel and many of your audience members are experts, not only in their respective industries, but also in the development and the management of your businesses. We still have some very early stage technical founders that are really developing, world-leading, industry-changing technologies. But they realized, and we exist to help them on the commercial requirements of those businesses. So what is our strategy of the PRN? It's purposefully one, to address these commercial gaps in our community. And more so, we have a very much an externally focused strategy. So our first goal was to truly define what we have in Pittsburgh, get a high level of engagement from our members and our stakeholders, and then to begin telling this story in worldwide industry segments. This is why we are very thankful for the opportunity to sign the MOU, and we really look forward to having productive outcomes from the relationship. I mean, of course, we are looking to create jobs in southwestern Pennsylvania and Pennsylvania and improve our economic environment. But more importantly, we believe to do that is that we can is to create those industry connections that help our companies grow. So we create the demand for jobs, here and in the United States. So what we do and how we do this is threefold. One, we promote both our member stakeholders and our external industry stakeholders. So we will put as just much effort into promoting you as partners as we do in promoting our regional companies. So we look forward to making these individual connections. We also work to connect stakeholders across our worldwide network. And, we do this through traditional trade association initiatives or tactics such as events and virtual meetings. I think one thing that would be very interesting to this audience is we will be facilitating industry forums. So we've talked about Industry 4.0, we've talked about security, we've talked about challenges in the labor force. We would like to get together folks across our entire networks and get into smaller, more intimate groups to discuss these issues. And C, finally, our third way that we look to make a difference is to collaborate around these issues and look for initiatives, as I mentioned, would meet our mission, which is accelerating, the overall industry. So what can your companies do? It's simple. Connect with us, participate as a part of this MOU, be a member of these discussion forums. We are interested in learning from your expertise in your target markets and from your long time experience. It's really important for us to understand what your requirements are and what we think the leading use cases can be. So, Chairman Lee just mentioned, what is the purpose? We have to define the purpose together as technologists and business leaders, and we need to know how to help prioritize those. And then there are really three main more things I think that you can do is be open to experimentation. We're still on the leading and sometimes bleeding edge of these technologies. Our companies, not just in Pittsburgh, but throughout the entire industry, are looking to take these early stage prototypes and solutions and pilot them. And we really need partners in that process early on. So I really do encourage experimentation. Second, I would like to look forward to collaborations with you as, industry corporations with our academic leaders in the region. So we'd like to make connections with you and Carnegie Mellon University and other leading R&D centers. And then finally, I wouldn't be doing my job if I didn't say this, we need investment. So if there are opportunities within your community or from a strategic corporate perspective, of course, we're in a capital intensive business and we have a lot of really compelling teams that are looking to solve the right problems. And we're constantly looking for capital to make those opportunities grow. And I think we are already seeing, in the electric vehicle space and other leading, investment spaces, these investments can, really be extensive and can lead to great returns. And, we're creating new industries. And so together with your expertise and our technology and the capital, we believe we can partner towards that future. Thank you.
All right, thank you, Joe, for sharing with us about the importance of collaboration and investment. Just a follow-up question: that are you able to share a little bit what are the international ecosystem connected with your region at this moment with local investment?
Yeah, sure. And we're still at the early stage. It may not be apparent, but even the Pittsburgh Robotics Network is only an organization that has been around for a couple years, and we've really only starting to grow within just the last 12 months. That said, we've already been making strategic connections, with the country of Israel. We look forward to opportunities in Denmark, another leading region of development, also in the Delft region of the Netherlands, and then in several areas, across Asia. So, there are I most recently was CEO of one of our companies in Pittsburgh, I Am Robotics, and we found that some of the investment interest and early adopter interest was stronger in Europe than sometimes in the United States. And there's a variety of reasons for that. But there are regions of the world that are either being a little bit more aggressive or the hurdles for testing and deploying technology might be different than comparative regions. Okay, sounds like you have a lot of international connection there already. Yeah, I remember that in the earlier days, each had some collaboration with Carnegie Mellon, but I think that we need to resume a little bit in that regard, doing some impact for R&D for the industries on both sides. Okay, my next question is for CTO Lien from Delta. In your presentation, you have shared with us about some pain points of manufacturing and also AI and etc. And just like to ask you to share a little bit more in terms of your company's global strategy of digital transformation, particularly on the customer side. And plus, with Delta, you are one of the pioneers from Taiwan in moving towards 2050 net zero. So just curious if you could share a little bit in terms of your global strategy of digital transformation and also your positions on sustainability.
Yes, thank you for a great question. As most of people know, Delta Electronics not only sell the product in Taiwan, but also mostly globally. So we do have a global manufacturing ability. However, it's still only in the few major spots. And nowadays, when we are looking for future strategy, we are seeing how fast we can move production line from one location to another and quickly replicate facilities much faster than what it has before. So we have three directions for the strategy. One is internally we set up a demo line, which we integrate a machine together, and from the manufacturing floor all the way up to the MES, which much quickly to switch the production line for different product types. And we have a dedicated team to set up to focus in this area. And once we have a need in the remote location, say America or India, or Europe, we be able to using this team to deploy our model line much faster, so we can making a good for our customer. Now the second one is internally we utilize smart design methodology. We design the product from the beginning in a much smarter way using simulation and also the integration. And this smart design can help us reduce the human error. More like, for example, the PCB, once you have a Gerber file ready, and then while SMT line is ready for production. So we transfer from Gerber information into the SMT parameters automatically and without human interruption. And that one, we can improve our production quality and also making a fast product out. Now, in order to do all of this, we have to standardize all the parameters, and which is very difficult. So we actually utilize the AI to analyze the historical information and figure out what production parameters is better for a particular good, and we use that to improve our production quality. So out of these three, that's our main strategy direction for us to do more globally production. Thank you.
Okay, so follow up on that reply of yours. It sounds like you have done a lot of this rapid deployment of your global digital transformation. So I was curious about Delta being a leading company in targeting the sustainability. So in your mind, how does your company balance between digital transformation and this pursuit of sustainability?
Yes. Our founder, Delta founder Bruce, now his vision, it's always making the earth more greener. So he spent lots of effort and time and money into this area. And for example, our San Francisco facility in Silicon Valley, we spent a lot of money to build a nice and big green building. And with that green building, and it reached the level that we save the rainwater under the basement, and we reuse that. And our policy is every single building we build, it's green. So recently we just built one in Europe, and we will build another one in Taiwan, and everything goes to green. So from the sustainability point of view, Delta is committed to make the earth more greener, and we hope all other companies can do that as well. Thank you.
Okay, thank you. The reason for my follow-up question is just that Taiwan is known for ICT and manufacturing, and there are more and more companies like Delta that is striving toward sustainability as part of the manufacturing and digital transformation solution. And it's a hard and difficult challenge, but Taiwan being a global citizen, we know this is the right direction for us to collaborate as well.
Yeah.
Okay, my next question goes to Country Manager Tam from Rockwell Automation. And I am very impressed with your presentation talking about assessment of maturity level for digital transformation. And given the fact that your company has a lot of industrial experience and observations in Taiwan, very similar question to others. In your opinion, what are the niche markets and opportunities for the Taiwan manufacturer that you have seen or worked with?
Okay, thanks for the questions. Thanks, Stephen. In my observation, before I answer the opportunities, I can see a lot of manufacturers in Taiwan or even globally, they are desperately want to move on digital transformations. They're starting to put a lot of money inside there, and they start very hard for that. Especially in Taiwanese, everyone Taiwan is working very hard. So normally I can observe that they not just putting money, but working on for that, but they try to do it by themselves. Okay? They try to build their own platform. They want to try to own solution for their company use only. However, I normally give them different opinion. I think nowadays, if you want to move on to the digital transformations, you cannot work alone. You need to find out ecosystem. You need to find out your right ecosystem, your right partner, have a right platform, then the platform, develop the tools, and leverage your own experience and capabilities. That's I would like to, I think is emphasize for that. After that, if you can up to that have this kind of alliance with your company, then you can look for opportunities. Without this alliance with the ecosystem, without this platform to help you, everything do alone, it will be very difficult. And I can see a lot of failure case in my experience. They hire a lot of people from IT, from other industry, try to do it by themselves. However, it's not as easy as they think, because people is keep changing and they don't know IT. So I would suggest them leverage a partner, focus on your experience and capabilities. Then right platform, right tools can help them to move on to the next stage. After you develop these kind of foundations, opportunities come. I would say it really depends on what kind of pain point you want to solve. Even you are in the same industry, I am very sure every factory, every company have their own problem. Even the same company, different factory, different problem as well. So once you have developed this platform, then you can sit back and think about what's your pain point. Some maybe focus about talking about energy saving. They think energy saving is one of their opportunity to improve their plant. Some even think they think they want to improve their product quality, and the product quality by finding out the root cause of the productions. And also very common in nowadays, they would like to faster to the market. They would like to let the customer know that they can immediate delivery by minimize their downtime, by improve their OEE efficiency of the productions, or even in COVID-19 situations, they try to use remote operation method to do the repair, training, everything. So I would see those are great opportunity for every manufacturer to focus. And every manufacturer have their own capability to find out which is the best for them. So again, first, build your home platform with alliance, with your partner, then find a pain point and pick what you want to do. Thank you, Stephen.
Okay, thank you, Charles, about this not being able to not working alone and work together with some type of platform and focus on the pain points. My last question for the first round goes to Robert Chen, country manager of Epicor Software. You have mentioned including the auto examples, and through in your experience, that just curious that if you have observed companies hesitating to invest in smart manufacturing, and what is your experience, and also how does your company fill that gap for either the Taiwan manufacturing companies or elsewhere?
Yeah, thank you, Stephen. Just share just my opinion. I think the IoT, Industry 4.0 is the skeleton, And smart manufacturing is the heart or the blood. So I really like the smart manufacturing, this two word, this term. It's not only about the manufacturing, it's about the smart. And if we want to have a smart manufacturing, that means we need to have a smart worker, smart process, and furthermore, I think the Taiwan Chairman Si just mentioned Taiwan have so many SME, and those enterprise like Delta or Foxconn, they are quite good. They understand where they are going in the next 5, 10, even 20 years. There's no problem. But for those SME, they didn't know where they should go. And now we give them the term digital transformation, or we give them the smart manufacturing. They want to know how to do it. They want to invest, but there's too many things that they can do. When we talk about digital transformation, is that MES? Is that the sensor on the machine? Is that the cloud or any others? So echo to Dr. Lee, that they need to look back to their problem. What is their current issues, and what is the next 5 years, 10 years they want to achieve, and how they can make their workers smarter, or the office worker can be smarter. And that need the I mean, it's internally they need a company culture to encourage their employee to be to continually improve. And secondly, I think the Taiwan SME or smart we're facing the external challenge. I'm not only observing the Taiwanese company, I also have to report to Asia or globally. And every time I need to compete with my colleagues in Southeast Asia, which concerns me a lot. Why? Because Epicor is, most of the companies came to Epicor. They are thinking of replacing their ERP or MES or operation systems. And it's the second time or third time they do such replacement. And further, and more, they are looking for Epicor because they are facing the make to order scenario, the small amount custom products manufacturers. So they came to us, and now I see a lot of companies. Epicor are doing quite well in Southeast Asia, and which means those companies in Southeast Asia, they are also for looking for the make to order or small amount custom manufacturing scenarios. So what I'm saying is we are facing the external challenges and the global competitive environment, and now our Taiwanese company must go for smart, not only for smart manufacturing, but they have to smart. We are not competing with other countries. Now we are facing the challenge from Southeast Asia, and I think there will be two ways. One is internally, they have to build a culture that encouraging their employee to continue improve. And secondly, they need to see the external challenge from other countries. I hope I answered how I can fulfill it. I just share this and help them to identify their pain points, their priorities, and how I can adopt the US management to help the Taiwanese company and all build on Epicor's platform. That's what I do here. Thank you.
All right, thank you, Robert. And that concludes our first round. So we can get into a shorter round for the second round. And as I mentioned that I will ask everybody a common question by quoting what Robert has mentioned from BCG, my ex-employee. The companies that have purposefully developed capabilities to tackle ambiguity and unpredictability are most likely to thrive. I think that echoes some of the problem and issue focused by Vice Chairman Lee and also Robert just now. So my question to everybody is that try to think a little bit, what would be the number one challenge or unpredictability or issues that you could think of in the collaboration between Taiwan and also Pittsburgh ecosystem altogether? What is the number one challenge that you could envision? And with that challenge, obviously that if we conquer, it becomes an opportunity, right? So what would be your recommendation for conquering that challenge? And it's okay to have people having the same answer to that. I think that it's almost like a quick round of poll on what every one of you think that would be the challenges. So I give you 10 seconds to come up with that number one challenge. And coming back to the purpose of this forum is about signing the MOU between Pittsburgh, represented by PRN, and also Taiwan, TAIROA, and TUSA, with the support of government from both sides, about smart manufacturing collaboration, and that includes AI, automation, and also Industry 4.0 digital transformation. So with that, let's go through your vote of the number one challenge and recommendation for how to conquer it. And we go with the same sequence. So first of all, Chairman Si, what would be your number one challenge?
So number one challenge is, first of all, I look at the presentation of the PI and Mr. Lee presented. It's very impressed. So the number one challenge I saw that is, since nothing can replace, how to say, face-to-face meeting with, take for example, PRN member, to know them personally, and to look at their capability, and most importantly is how can we cooperate persistently. I think this is the number one challenge I see, because according to my own personal experience, our company, Highway Microsystem, I work for other private company as Highway Microsystem. This company have a long-term cooperation with U.S. leading semiconductor industry. So during this last 2, 3, and 4 years, we provided a precision module and provided the service here around the global. And so that we enjoy the growth of semiconductor industry together. So this kind of cooperation lasts, take many years. But we need to start from face-to-face and to know each other. I think this is my challenge, because we are eager to meet the members and in PRN and in Pittsburgh, and we need to know the capability to discuss opportunity, etc. That's only the starting point. This cooperation will be should be long term. So that is my the number one challenge. We need to meet each other.
Okay, need to meet each other. I'm sure your recommended solution is to start as soon as we can conquer through the COVID situation. Okay, like I mentioned, we don't have to be different. So don't change your number one challenge vote as we hear from each other. All right, so next would be Jay. What would be your vote for number one challenge and recommendation for conquering that challenge?
I think we got to find the common dovetail the gaps, right? So the Taiwan has a different issues and Japan has different issues. Every country have different issues. So if you define industry problems, I don't think any one company can solve, because this is a huge ecosystem problems, supply chain problem. But if you talk about social problems, social markets, like healthcare problems, that's pretty much common. That's why Japan has a society 5.0, trying to solve the aging population issue. So if you target the robotics or whatever in the healthcare industry, and no one can win by themselves individually. They have to work together. I think those is a good unmet needs, right? To me, is to find a common problem unmet needs, and which has a large scale of growth, not just a narrow problem from industry. I think that can help to formulate the purpose.
Thank you for pointing out that finding common needs. I think in your presentation, you also talk about resilient manufacturing system. I think that nowadays this resilience could be applied to manufacturing, also could be applied to solving societal needs, like you mentioned in the healthcare, yeah, especially beyond this COVID challenge. All right, so next one is Joe. What would be your vote and recommendation for conquering that challenge?
My immediate thought, and I've stuck with it, is inaction, or stated another way, committing to act. We're looking at a new opportunity for many of you and for us. And so, you know, my recommended solution to this is to move quickly, even move in an incremental or agile way. And let's find a way to, and I really appreciate the last answer, because I do think we need to find out where those overlapping areas of interest are. And if we can identify those out of the gate, then we should find you know, a lower threshold for acting in the short term, and then start building upon that, you know, as two areas that are still going through an introductory phase and trying to figure out where the opportunities are. Many of you and also our companies have existing priorities that you will go attend to today. We need to make sure that we can follow up on the spirit of this partnership and start you know, finding early successes, and then move quickly and incrementally from there.
Okay, thank you. Commitment to actions, however gradual it is, right? Yeah, so that's what we are doing today with the start of this MOU. The next one is CTO Lian. What is your vote for challenge, number one challenge, and recommendations?
Well, my vote is it's difficult to meet. That will be the first one. However, there is a solution, like Joe mentioned, that we can come from the introductory understanding to see what they have, what we have, and then find out what type of technical issues we can cooperate with each other. So during this COVID, I think COVID probably will be gone by next year. And actually, I'm start to traveling next week. So I think next year, people should be able to travel around the globe freely. And by that time, we should have even more in-depth mutual understanding when we meet in person. But Before that, I think we should have earlier introductory for what capability in Pittsburgh has, and then what can we fit in for that. Thank you.
Okay, thank you for that advocate of traveling soon. Then next is Charles. What is your vote?
I think in my observations, I would think IT and OT integrations is the biggest challenge in the industry manufacturer. So a lot of, from my observations, they have different teams, different people, different background, and different leaders to lead for the factories. So it always have a lot of argument between, and is very difficult for a company move on to the smart manufacturing, because without the integration of both departments, it's really hard to have a real data analysis and connect all the data together to do the next step. So to solve this challenge, normally I would recommend the manufacturer own very senior leader, even the board of director, to deeply involve all the digital transformation projects. Because I can see if they just depends on the middle level to do it, not leading by the top leader, there's always an argument between different departments. So once the leader step in, lead from example, show the determination to the company, they want to move on to that, it helped a lot to solve a lot of integration problems. So I give an example. Recently, I have been involved Taiwanese pharmaceutical manufacturer. They have no plan for doing new plant in overseas or in Taiwan, but they would like to improve their productivities in Taiwan old factory in the brownfield. So they, after the integration of IT, OT solutions, we can show the dashboard, we can show all the problem to the owner, tell them, hey, this is the problem. The first time meeting, we showed to the owner, and we thought they will ask a lot of questions for us about our system, about what is what. Funny that is a very funny experience. The owner didn't ask me any questions, but they asked the employee why there's a downtime, why there's a bottleneck in the productions. They found out that, oh, they realized there's a lot of problem in their plant, but they never thought about in last 20 years. So this kind of combination of IT, OT definitely help the owner or the decision maker can see through whole plant, where's the problem come from and how to solve it. So it's bring up the first step to the digital transformations. Yep, that's what I would say.
Okay, thanks for the mention of IT, OT integration, especially from top down. I'm sure that Vice Chairman JD and also CTO Lian have done a lot of top-down examples within their companies. The next one goes to Robert. What would be your vote?
I will say resilience. That means how company can survive in downtime, but when the economic come back, and how they can move into thrive, and it's all about the mechanism that the company can prepare worst, but plan for growth. So how do they prepare worst? That which means they need to have I would say have a mechanism that from every perspective, like they can prepare ahead. Like the once pandemic come back, then all the worker or all the production cannot function. So how they can manage it. So such things, I would say resilience and prepare ahead and have a mechanism for it. That's my answer. Thank you.
All right, thank you for your mention of resilience. I think that about from 6 of us that we have 5 to 6 different types of challenges. But as I mentioned that, if we start doing things, conquering these challenges, the opportunities will lie ahead. And since we are just about out of time for our panel, I think that through all your insightful presentation and also panel discussions, our online audience, roughly over 90 people today from Taiwan and US and other parts of the world, maybe, that we do hope that this is the starting of a long but fruitful journey of collaboration from Taiwan and US side. And with that, thank you again for attending today's MOU and also panel discussion. And hopefully that we will work together on this long journey start from now on. Yeah, so with that, I will give the time back to Raymond.
Thank you very much to Stephen, our moderator, and also 6 of our panel speakers for their valuable input. It is exactly this kind of insightful discussion and collective wisdom that we need to move the industry forward. Ladies and gentlemen, and all our friends who join us online, 2021 the Taiwan-US Smart Manufacturing Summit and MOU signing ceremony on industrial cooperation has come to an end. We'd like to thank once again for all of our speakers for their insightful and wonderful presentations. Most importantly, we thank you very much for your participation. And right now, you can see a QR code shown on your screen. Feel free to scan the QR code, leave your comments or feedback for us. We value your opinions very much. Thank you once again. For our friends in the US, have a great evening or have a great night. For our friends in Taiwan, have a good day. Thank you again, and we'll see you next time.